to the mix, right? So I'm going to use page 23, this equation, and the one on page 24, that equation. I want you to put them into y1 and y2. And the reason why I'm going to do that is because you need to learn very quickly how to adjust your window. I know that some of you are just using Zoom Fit or Zoom, one of the Zooms. That may work for you, but I would argue that you don't really need to use the Zoom for sinusoidal. It's actually quite easy to find. So if you have these into y1 and y2, can you just make sure the equal sign for y1 is right now turned on? You don't want y2 turned on. I just want to graph one at a time. Okay? If you hit graph, let's see what happens. I don't know what's going to happen on my calculator. I'm going to try graph. That's what my y1 looks like right now. It's not a good graph. I mean, at least you can see something, but you don't really need to see that much, okay? So I'm going to go to my window. Watch what I'm going to do here. Y min, sometimes it's better to just go a little bit to the left. Something negative, right? 0.5, -1. I adjust as the graph requires. For X max, watch what I do here. You should probably do that on paper, okay? You find the period because you have the equation, 2 pi divided by b, that is your period right there. So I'll go 3 times 0.43 for my X max. I actually type it in like that, okay? So now I have my sideways scale figured out, or the window from side to side. And for my Y min, you can do mental math, or you can just, if you go D minus A, that's 0. So this could technically be 0, but I'm going to go a little bit into the negatives, like I'm going to go -5 or something. And my Y max is D plus A, right, which is 6158. I'm going to go to 65, right? Just bump it up a little bit so you see a little bit more past the graph, right, on either side. Then I'm going to hit graph. That's a pretty good graph, okay? Sure, you can just do it by guessing. Some of you are just going to guess. Be my guest. But just keep that in mind, okay? Word problems. When you do graphs with word problems, you are going to be interested in that y-intercept. Okay, you're going to be interested in that. Most of the time, you want to include that. In fact, I'm going to graph this with you right now. Maybe we should do it now before we start doing the y2, right? The other question, let's graph this right now. You have space, right? You should have a lot of space here. So if you can just grab a ruler or something that helps you draw straight lines. If you're just going to guesstimate today, that is fine. But here it is. So for the graph, okay, obviously we're interested in the positives only. How far to the right should I go? I can check my window, right? I go 1.29 is the furthest I go. So maybe I will do this. Okay, watch. If a period is 0.43, it means that the period is very small, right? It repeats a lot of times. So I might go like this. This is 1. No, sorry. Let's see. Can I do 0.1, 0.2, 0.3, 0.4, 0.5? No, that's not going to work. So I'm going to go 0.25 at a time. So this is 0, 0.25, 0.5, 0.75, and then 1. This is 1.25. So I'm going up by 0.25 at a time. Okay? You know what? Even that is not a good idea. Where is it? This would be one cycle. Yeah, this one works. So along the x-axis, we're going to have time in seconds. And in terms of my y, what's the lowest I ever get to in terms of the y? According to this. We already determined that previous lesson. I already determined that, right? The min is d minus a, which is 0. The highest is 61.58, right? So I actually, this particular graph, I'm just going to stay above the x-axis. Okay? This is height in centimeters. There you go. I'll probably give you a grid most of the time, but you should be okay with this. Okay. So I'm going to try to see here. This would be, I need to go as high as 60 something. So 10, 20, 30, 40. I'm running out of runway here. So guess what I'm going to do? That's why they invented erasers. I'm going to erase some of this stuff here and make this work. So 10, 20, 30, 40. 50, 60, and then some. That's going to work for me. So this is 20, 40, 60. Okay? So you got to be creative with your scale. As long as it's consistent, you're fine. Good to go. So where do I start? I would find a max and I would find a min. Okay. So I grab my calculator, graph this. This is where everything starts right here. So I'm going to focus on maybe that min right there. That's the first thing that happens in this case, right? A low point. You're with me, right? That's the first. So I'm going to go second trace minimum. I have to travel quite a bit. There we go. Enter, enter, enter. So I will just make a note on the side. First minimum is at 0.02. And what do I tell you about this one right here? What is this number? 1.89, Mr. Erickson, because I can see it. Or 1.90. It's hard to see. You can't see that, but that's actually 0. Okay. That is 0 because it's got the e to negative 8, so it's this. Okay, that's the first minimum. And then I'm going to find my max there, second trace max. Enter, enter, enter. So first max is 0.23, or actually 24, and that's 61.58. No surprises there. Okay, that's what we expected to be the max. And to guide me, I'm going to have this just a little bit of a dashed line up here. It's going to go between there and the actual x-axis, right? So the first is right here, and 0.24 is right there. And what do I add every time? I add the period to get me to my next max. So you might want to get your calculator. You type in 0.24 and you add a period to it. So that's 0.67. I had nothing to do with this, okay? 0.67 is right about there. Add another period to this. That's 1.1. 1.1 is right about there. So if you have 3, you're guaranteed to have 2 cycles. They don't always ask for 2 cycles, but if you gave 2 cycles, you're usually more than fine. I'm going to do the same thing, 0.02 plus 0.43 to my low, that's 0.45. 0.45 is right about there. I'll add another period to that. That's 0.88. That'd be right about there. And I'd say that's good enough. You go from the low to the high, right? And then back to the low, back to the high, back to the low. Isn't that pretty? Okay. And let's go ahead and find our y-intercept. How do you find y-intercepts with the calculator? Second trace, value, x is equal to 0. It's at 1.37, right? So I'm going to write that down here. Y-intercept is 1.37. So it's very hard to make this appear on the graph, and chances are the province will make sure that it's not that close to your origin. But technically we could handle it, right? So you've got labels, you've got scales, you've got the y scale, the x scale, everything is good. One thing is missing though. If you're interested in full marks, okay, so that's how you do that. All right. Okay, I'm going to give you a bit of a crash course. I'm not going to go in detail, right? But you just got to make sure you follow along as best as you can. Okay, so page 24, and then you'll do the AC. Whoa. Okay, 24, where are you, 24? I need to see 24 here on my key, otherwise I'm going to get it wrong. So right off the bat, you know it's a sinusoidal, no doubt about it. I will do my inventory. Should I do it here? I'll do it here. Okay, so your max, you're going to go 519 plus 1635. And so you know the highest this ever gets to is, help me out here, 2154. And the lowest this thing ever gets to is 519 minus 1635 is going to be negative. We're in the negatives here, and the min is negative 11.16. So definitely not Winnipeg. Can't be Winnipeg. Should be minus 40, right? The midline, what's the midline? Like, it's like average. That would be the average, guys. If this question had asked you, what's the average temperature? It would be like the midline, okay? So we've got this figured out. Let's keep going. Let's figure out the period right away. 2 pi divided by 0.0172, right? This is B, the B value of our equation. I get, it, not surprising because this is the temperature in a year, 365.3015, something like that, right? So we know that one cycle, after that it repeats itself, right? So it repeats itself every 365 days, more or less. Right? We all know that a year is not exactly 365, right? That's why we have the leap year, right? Every 4th year is a leap year to make up for that. So anyways, that's a period. So now I grab my calculator, I type that in, make sure there are no negatives anymore. The only negatives is the leading coefficient ever, right? I'm going to try to graph it. I don't see a thing. Window. I'm going to fix my x max first. It's going to be 3 times 365. Yes, you can just put in 365. It's going to be good enough. Let's see. My y min should be negative 12 or negative 15. The highest is 21, so I'm going to go up to 25. Okay, so that's my window. Let's see if I see something. Beautiful. Okay, I now see a lot more. Let me see if I can change the contrast. There we go. So we're good to go. Now you can answer a bunch of questions based on that, right? But finding the graph is like half the battle sometimes, right? if you see that, it's probably not very helpful. You're seeing a lot of cycles, right? So that's why I do the trick. No, that's also not good. What was it, 1800 or something? I use the trick of 3 times period to figure out what the spread should be so you don't see too many cycles, right? If we were to graph this, now you're going into the negatives, right? So I'm gonna quickly show you. It shouldn't take you longer than 5 minutes, to be honest. What? It takes me like half an hour. Well, at some point it shouldn't anymore. So I'm gonna do this as my x-axis, representing time in days. Yeah.
How much periods would you want for the graph?
Usually 2 is what I would recommend. If you do 1 cycle today, because I didn't specify, you're fine. But oftentimes the province says, make sure you include 2 cycles. So I always tell my students 3 caps or 3 valleys, right? Just make sure you have 1 period and another period, and then you're good. So if I have 3 periods, that's 3 times 365. So it's 1,000 and 1,100, 1,200-ish. So I want to make sure I go all the way to 1,200. See, look at this. It's going to work 100, 200, 300, 400, 500, 6, 7, 8, 9, 10. That's 1,000, 1,100, 1,200. So for me, that works perfectly. I want to try to spread it out. So this is time in days. This is temperature. What is it, degrees Celsius? Yeah. Make sure you have label and units. And I'm just going to label every other one. 200, 400, 600, 800, 1,000. Okay, I've got my scale. This one, be strategic. I'm going to go negative 15 here. 5, 10, negative 15. And I'm going to go up also by 5. So you can't change that. 5, 10, 15, 20, 25. Okay, so 5, 10, 15, 20, 25. Okay, so that's good. My cap is at 21 point something, so I'll just make a dashed line to help me out. And then minus 11, it's right about there. Okay, so I've got my top and bottom caps. What's the first min? The first min happens at, I'm just going to go off my key here. Is it at 15.6 something? Okay, so 15.67 and negative 11.16, that's my first min. And my first max is at, help me out here. I've done it differently in the past, that's why my key. Yeah, the first max is at? And that is at 2154, yeah? Okay, good enough. So now I know where to start. So 15 for me, if this is 100, this is 50. 15 is right about there. That's at negative right here. And the first max is at 198, so it should be closer to 200, and it's going to be at the top here. Okay, so now I'm just going to add 365 every time. So watch this. It's just use your calculator. If this is 198 in terms of my y, you add a period to it. So the next top should be a 563.63. This is 500. This is 563 is right about there. I'll add another period to it. Here you have to try to include as many decimals. 928.93. This is 950. 928 is right about there. Just make sure the spacing looks about the same, right, from cap to cap. You do the same thing here. Sorry, I kind of 15.67 plus 365.3015. That's at 380.97. I'll add another period to it. 746.27. The 746 is right about there. There you go. What's the y-intercept? It doesn't ask for it, but I'll find it. It's at negative 1057. Negative 1057, so it's right about there. It's very hard to make that appear, but there it is nonetheless. Okay? So that would be a pretty good graph. What is the meaning of the period in this situation? If you had to use your own words. It takes 365 days for a full cycle where you go through all the seasons, right? And then it will repeat itself. Okay, so I will say this. In this case, don't just say it's the horizontal distance between the two x values where it repeats itself. Put a context to it. The number of days. It takes for the average temperatures to repeat themselves. I will just make clear, I would like you to on the exam or on a test just say temps go from low to high, then back to low. Okay? An explanation can also go like this, where you say from here to the highest, back to the low, you say that this is 365 days. Okay? Then you're making sure everybody understands, you've made your point very clear. I want to talk about the question C. Is that one all right? Question C. It's a little tricky, but I will do this with you. When is the temperature at 10 degrees? So when, that's the time, is the temperature 10 degrees for the first time? You go y2 is equal to 10. Second, trace, intersect. Let's go ahead and do that. I'll let my y3 be 10. There it is. Second trace 5. And you want it when it happens the very first time. So we go all the way to that first instance, hit enter 3 times, and you get 124.3610. It takes 124 days, more or less. But I actually asked you like exactly which day. That's kind of annoying. How would you know that? Okay. But if you had a calendar on hand, give me one sec. Give me one sec. I'll come and see. If you had a calendar on hand, do you know the knuckle rule for days? Every knuckle is 31 days. What is this called between knuckles? Is 30. So January, February, March, April, May, June. June always has 30 days, right? July, but then you got to cheat. Watch this. July, August. Did you know that July and August both have 31 days? September, October, November, December. Okay. Anyways, that's the rule. So if you do the math, 31, February usually has 28 days, March has 31, April has 30. If you do the math, if you add that up, and then keep going, it takes you to May 4th or May 5th in this case. Just about. So you add 31 days, or maybe subtract. You go 124 minus 31 minus 28 minus 31, subtract the days, and then you'll be narrowed down to just a couple of days left, and it ends up being between the 4th and 5th of May. May 4th. May the 4th be with you. Anyways. So that's how you would do something like that. I don't expect them to throw something like that at you, okay? I don't expect that. Has anybody done D already? For how many days is the average temperature below freezing? Has anybody done that one? What is freezing? What is it asking you here? What is the temperature? 0. And look at our graph, right? For how long? This is the 0 line right here. So we need to find out how much time goes from here to here, because we're considering one full cycle. Go ahead and find these two intersections here, please. Let y2 equal to 0. Find both of them. Write both x values down to 4 decimals, okay? Let's do that, and then I'll answer the rest. I need you to be a little active here. For this one, let's just do a little visual here. It goes from here up and then back down. We're going to stop this picture right there. That's a full cycle. This is your y is equal to 0. Below freezing, what stretch of the curve are we interested in? Below or above the, yeah, this is my freezing line. We're interested in this stretch, right? Yeah, go ahead. We're interested in what happens here and here. We want to know how long are the temperatures up, like below that freezing line. So let's figure out time 1 and let's figure out time 2. Have we figured it out already? Anybody care to, do you have the numbers, Hazel? Can you give me the first one, this one? Okay. And the second one? Is that right, the way I copied it? Yeah. Okay. That's right. So if we subtract these two, what are we going to find? What happened between those two times? You were above the freezing line, right? But we want below the freezing line. So let's subtract first. This is 308 point something minus 88.21. You just have to read carefully on this. You would already get marks for this part. If you do this, delta T, you get, let me just get this right here, 220.2111. But what did I find here? Let's do orange for hot. I don't know. When you subtract, you're finding out what happened between those two times, which is above freezing. You want below freezing. How would we find below freezing? What is a total cycle from here to here is what? 365, right? Can we subtract this from 365 and then be left with below freezing? Yes. So time below would be 365.3015 minus 220.2111, okay? And that gives you 145.09 days. Definitely not Winnipeg, because Winnipeg is like 359 days below freezing, it seems, this year. Okay? So that is what we wanted all along. And yes, I took you for a long ride, okay, on this one. But anyways, you just have to read carefully. This is kind of like parabolas, right? Quadratics meets the other functions, right? When you have a curve like that. Okay, I'm gonna stop here.